Hello one and all. Today we are discuss about the simulator, IoT simulators. So Arduino simulator, which are the virtual representation of the Arduinos. Just a minute. Yes. Uh, and basic advantages of that is it is easy to teach and learn how to code the Arduino and build the circuit anywhere using only computer and internet. So no need to use the different hardware, need to purchase that. So that complexity is not here when we are using the simulators, and it is much easier to find out the hardware and wiring errors. Otherwise, if we are wrongly connected the connectivity between the wiring, so there is a short circuit and we can lose the device. So we can avoid that also in the simulator, and no need to struggle with the messy wires in that actual circuitry. So also we can and share the design with a peer student. We can discuss that the important concept involved in this, those we are doing now. And the disadvantage is also there. Obviously coin has two sides. So disadvantages are it is limited components available, whatever available in the market. So all components are not available on the simulator. And whatever the good simulator, it is not a free of cost, we have to pay for that. And the internet and Wi-Fi connectivity may be possible to that. So the basic simulators is used for designing, preparing, and connecting the hardware circuitry. And whatever design code, then we can shift it to the actual hardware. So whatever the simulated functionality, if it is working properly, then we can shift it to the actual hardware using this virtual replica of that and avoid the errors related to that and loss of the device. So basic online simulator, which is free of cost and very easy and handy to use. That first one is the Tinkercad. Today we are demonstrating the Tinkercad. Then next in 2020, the very famous and but somewhat complex simulator, that is walkie simulator. But the features and all that things good, but little bit complex one. Then Circuito IoT, circuito.io also we can use. These all three are online available and free of cost. The next one, that is an offline simulator, that is Simu Dion. Then Arduino Sim, Umulator, Arduino Simulator, Vertronics Simulator, then Proteus, and the Simulites. So this offline, but we have to pay for that, but these are very good simulators. So this is the screenshot of the Tinkercad, and this is working. Now I am going to demonstrate the Tinkercad. So you just Google Tinkercad. And just click here. Go to login, then sign in. Sign in with the Google as per your requirement. Then use ID. You get welcome message. We have to work on a circuits. So you have to click on circuit, create a new circuit. So we can rotate that and all that thing. So these are the basic components which are available for startup, and these are all available in the particular Tinkercad. So these are, if you want to see the list, so we will get the information related to each and every component. Now I will start with I want Arduino. So I just write here Arduino and I mention here. I want to resize that. So control and minus. So I can just reduce the size of this one. So it is not plug. I can rename that. Then if I want just one piezo, okay, which is a type of buzzer that makes a noise at different frequencies. Second, I want this one, so I just take that. Now there are 4 types of wires: normal, hooked up, alligator, and automated. I am using here normal wire, and I can also select the color of that wire. Now, the piezo has positive and a negative. So on a positive, I am consider the red wire, and I connected that to the, sorry, I connected that to the ground, and on this one, I select the green one. Sorry. Here, I consider the next one and put that at pin number 13. And to differentiate both the things, I change the color. So I just switch on this buzzer. So I have to write the code for that. So code is of 3 types: block and text, and text. So block, this is for school going children, just take a blocks and connect with that and write a program. So as we are much more comfortable with this text, this is just C++ code. So the sample program is written here. So first the setup, that is pin number 13. So I have to consider here pin number 13 and provide the output to that. Then I write here the loop. In that I mention the digital write at 13 pin, voltage is high, and delay of 1 second means 1000 millisecond. And then after that I put here write, okay, on this pin I write 13 volt, and I'm just power down, that is a low, and delay of 1000. So this is my simple code. Just ground, I connected with the ground, and on 13 number pin I mentioned the code, and I start simulation. You can hear the voice. It is connected and it is working properly. And we can, if we want to rename that, we can just rename that with some proper name. Okay. Now, if I want to consider the breadboard and some more components. So there are a number of breadboards. I select here small one. So it is selected. Now on that I want to consider LED. So I take that LED, put here. I can select the different light color. Then here is this cathode, and this is anode wire. I just take this anode with ground. Okay, so for that I just make this connectivity, and this I want to set to the pin number 13, because I am again consider next component, that is again piezo. Okay. So this I have to again connected with a ground, and this I'm connecting to, for proper shaping, I just click here and then come here and then come down. If I want to make it straight, so look wise it should be better. Otherwise, this is messy and you don't understand which wire is going from where to where. So that's why, to avoid that confusion, then I'm say that the grounds, I make the wire color red, and whatever the working one, that I make that as a, I keep that as a green. Now here, one more and most important thing, here it is, the breadboard is divided into 4 parts, and these holes are connected horizontally, you can see here, and these are connected vertically. These are connected vertically. Yes, if I want, I can connect here one resistor also, so that it will not affect to LED. Otherwise, there is, if the voltage is high, then there is chances to few goes off that LED. So I just consider the capacity as 20 ohm for that LED. Okay. So now you can see this wire is connected to the terminal 2 of this resistor. This is connected to the terminal 1, and we can come here. So we can see here it is vertically connected. This is one compartment, from that we are coming here. We can directly connect here also and then come here. Okay, so please take care of this thing. Okay, so we are added resistor. Now we have to join this negative to the ground. So we just connected this both negative to the ground. So this is my simple circuitry, where my aim is to just 1 second delay on the light as well as piezo, okay, and off that. So for that I have to write the code. So I consider the example of this. Now I am setting here pin number 12 for piezo for output purpose. That's why I just consider 12 as an output. Now I have to on that. So I write, and my piezo should be buzzer, and I make it off after a certain time. So both should be simultaneously start and stop. So I just complete this coding part and start simulation. So you can see here light and piezo both are working simultaneously according to my code. Connectivity is proper. So likewise, we can design, we can code that. If you have already written a code in ID, you just copy paste that here. In our code, you can just copy paste that, design circuitry and use that. Now, you don't understand connectivity, sensors and all that thing. You have to study more. So for that, you have to go to the just before that I want to show you. Yes, this is LED bar. So I just tinker this. This is my existing program. Okay. So there are 9, and this is LED bar graph. So as potentiometer I set according to that this is working. So this are connected, this negative are I am putting in a ground. Okay, you can see here it goes on the ground, and this one, this anode one, I connected with the resistors, and for that I am consider the pin number from 2 to 10, that are the 9 pins for this 9 LED, because one by one it should start and stop. And then I consider this potentiometer, which having the 3 pins, that is terminal, wiper, and the terminal 2. So terminal 1 I can set as a ground one. Then this wiper I set to the analog pin, because the analog things is considered with the help of that. And this is I set to the 5 volts. Power supply is going to that analog through this particular terminal 2. Terminal 1 for ground, and terminal 2 for the power supply of 5. Then the code related to that. So I consider the analog pin A0. The LED count are 9, and that pins are from 2 to 10. Now I make a setup for this LED, means one by one I have to blow that. So 0 LED count according to that 9, one by one I have to start that. Pin mode of this LED means according to this setup, it will increase and show you the output. Now in a loop, I consider the sensor reading of that analog pin, means from this the reading is read. Okay, so if the level is mapped to the sensor reading between 0 to this particular count, then you have to consider the LED count. And for that, we are considering LED initial value 0, okay, up to 9, and one by one we have to increase that up to completion of that LED, and we are writing that pin high, else we have to write it should be low, means down. So this is my code. Now I initialize that. So my program is starting. We can start that, and we can see here all are in a glowing position. These first two are off. So I just increase the, you can see here one by one. Okay, so it start from here, and one by one you can see the LEDs are switching off. Okay, now again we can start this. So according to that we get the results. Nice one. Okay, so the next one, this is just I run that according to this sensor. Buzz. Now, if you have to learn many more, then go to this Learn tab. Okay, you have to select here circuits, and then you search which type of circuits you want. So there are some ready-made circuitries. Okay, so go to circuit, search, and circuitry, and if I am saying the clock, and search for that. So you will get the different clocks, analog clock, and likewise. Nice. So you can take all this thing, otherwise display. So you want to just say hello message or 8 circuitry, Likewise, otherwise this 8 should be so connectivity and all that things. Hello. So I will select this one. Okay. So you have to just copy this to understand that. Otherwise, from here also you can simulate and see the result. Is it working properly or not? So I just simulate that. Here is also piezo. So, yes, simulation. And I can see here, you can see here. You can see here, hello IoT. Now, if you want to read and understand this code, then you just copy that. So it will copy and paste in your login. So this is available now, copy of this. Now the code is available. You have to just understand code. LED from 16 to 2 and it print on this LCD, hello IoT. Okay. For that there is a delay of this and you can see the result. So you can see and you can understand the code. So you can learn many more ready-made one from this learn. Okay. And one more thing that I will tell you. You can change the name also. You can tinker this. Yes, you can share, export that. You can use that code. You can share that with anybody. And whatever the components are used, what is the quantity and all that things, that also we can see here. This is circuitry and this is the list of component. You can download that also. If you don't want that, you just go here and you can delete that. Otherwise, whatever your repository, you can store that in a repository. So that's all about Tinkercad. Thank you.